blessed, why won't this work? There we go. So to undo a fourth root, you fourth it. So if you fourth both sides, fourth root of something to the fourth is just the something. Bless you. Thought I sneezed. And then 3x to the fourth will be 81x to the fourth. And then you fourth root it. Yes, sir. But there's a plus one under it. It would be great if you could, but you can't. So I just felt like throwing a wah in there because I haven't done that in a while. Yeah, right. No, I can't. I can't do that because of the plus sign. I can't split that apart. Because if it was multiplication, you know how we've done that with the monomials with the square roots and the fourth roots, we see how many times it goes in and all that, and you can do it. But as soon as you put it in there with a plus or a minus, you can't do that. That rule no longer exists. So when you get to this part here, you've got the fourth root of a fraction. You can take the fourth root of the numerator and the fourth root of the denominator. What's the fourth root of 1? 1. Now, I get that, right? Oh, did you simplify that out? Well, to every fourth is, I'm sorry, but very fourths. You said 5 and I was right. I just wrote that. Now, you can do one of two things. If you're looking for a perfect fourth, the closest one would be 16. I didn't think of that. We did it the other way around by just rationing through. If I go with 16, if I do 80, 80 is 16 and 5, isn't it? So then I could take that and rewrite this as 2 fourth root 5. What's the fourth root of 16? Okay. I didn't think about doing it that way because now you have 4 to the 5th. Excuse me, 5 to the 4th. I think it's one of those. It's not. How many more fourths do you need to make a whole there? 5. You need 3 of them. So now I get 5 to the 3 fourths over 2 times 5, which is 10. So this would be the fourth root of 5 cubed over 10, which doesn't look like it's much more simplified than the fourth root of 1/80th, but technically it is. Yeah. What I will try to make sure is to, with numbers like that, yeah. What I will do on the test and stuff like that, when I get to the weird equations, weird stuff like this, I try not to throw too many coefficients in that you have to worry about simplifying through, because those can get really nasty if you're not careful. Especially, I mean, I missed it. We just did it in Flex. You can so easily miss it, but get all your powers correctly, if that makes sense. So I do my best to kind of not use as many coefficients that you're not going to be able to recognize. If I had like square root of 80, you'd say, oh, there's a 16 in there. You would pick up on that, but I wouldn't be like a 4. I mean, that's just speaking of weird. That's a joke. Sorry. You used a decimal? You used a decimal? But it gave you start the problem in nth root, so why wouldn't you finish in nth root? least you're honest, so I won't get mad at you today. Make sure you. There are a couple problems on here where you had to take was the one where you had like the negative 2/3 power of like 12 or 6 wasn't it one of them? Yes, 6 to the negative 2/3. Yeah, you're gonna get a crappy number for that. That's fine. Yes, ma'am. 50? Sure. All right. So in order to do 50, you have a cube root on both sides, which means, guys, I'm not talking over. You have a test tomorrow. You have to do what to both sides? This is freaking easy. What do you have to do to both sides? Cube it. So if you cube both sides, what do you have to do with the 2 out in front? That SQ. In this case, I can cube the 2, and it's not going to be a problem because it's not a plus something to it. Okay? Yes, sir. You can, but it doesn't. I don't think that helps you with anything. Because if you divide by 2, then you'll have you're going to wind up with 2 minus x over 8. Yeah, I see where you're going with that. You can do that, but wouldn't it be easier just to do this? Because then you automatically get where you're at. I mean, you're not wrong. You didn't multiply the other side. Oh, you didn't write it as 8 times 2 minus x, did you? Okay. Okay. Yeah. What you were doing is it's not wrong. You wind up in the same place as we did. Okay, it's fine. So then you wind up with 80 minus the 24x is 2 minus x. What do we get? 78 is 23x then? And you just get some crummy number? Yeah. It's okay. You just get a crummy number. We did all the process right. You're gonna not all these things are clean. It's just a matter of going through the right process on it. Yeah. Yeah, I would add the 3/2 cube root of x over it, and then cube it. You get 9/4 times x, and then you work backwards off of that. And I think you might have another crummy number. What is it, like a 111 and something? Yeah, I knew it was an 11 in there somewhere. Yeah, you just might have a real crummy looking number in that case. But it's the same process. Okay. Yes, ma'am. Mm-hmm. You said 38? Okay. What would you do first? By what? If I'm already multiplying by 2/5, how do I undo it? I multiply by 5/2. You gotta go with the reciprocal. So multiply by the 5/2. So now you have 10x plus 6 is 30. Okay. There you go. Oh, I meant to square it. Thank you. Hi. 900. You get to be fraction. Yeah. So it's 900 to be 894 divided by 10. So it's 457 over 5. 47. I think there was. The rest of it's pretty straight. Now, with the test tomorrow, if you go through what we have for Chapter 7, yeah. Sounds good. They have a thing up in Minocqua called Beeforama. Uh, I just really want to go to it. That's why I keep saying it, I guess. So. What's that? Nope, did not know that. Nice. You gotta have barbecue. So, chapter 7 stuff, you really go back through what we were at. We started with, we did what, 7, 1, 2, 3, 4, and 6, right? Yeah. And if you're really going into this, this is generally one of the shortest chapters or shortest sections that we talk about the whole school year. Between this one and eventually when we get to sequences and series, that's also, I think, only about 4 sections long. So there's a couple of quick hit like style problems like this. And if you think about what the first few sections entail, these first few sections here all kind of dealt with the same thing. Your power rules, didn't they? They all dealt with all those power rules, but yet you had fractional exponents, you had to rationalize, you had to bring out and multiply by fractions, simplify things through. And it wasn't so much that it was always like x cubed times x to the 4th, and figure out what that is. No, it was like x to the 3rd times x to the negative 5x, and you had to work through those. So we did that for 7.1, 7.2, and then 7.3, you started talking a little bit more about the combinations of them, f of g of x, things like that, where you would take one value, substitute it in the other, and go. When you got to 4, that's when you did your inverses. And that's where you just flip-flop your x's and y's and resolve. 7.6 then yesterday was just solve for x. So as you go through it, if you really, really, really get into it, the majority of the work that we've kind of looked at always kind of goes back to the idea of your exponent rules. And I think really the only weird thing with some of the exponent rules that we come across is that we just have to be conscious of them, right? And what I've done is I've taken a good chunk of problems. Good old CUDA. CUDA is the best thing ever. Yes, sir. Look at terror when you said it. No, it's the 5. What do you want? What you're going to do is you're going to graph one, graph the other. What are they equal? You got 4 or something and actually something. What are they equal? Because they have to equal each other. You put in the graph calculator to the intercept. That's all you find out. Yes, sir. I can't hear you. So a lot of times, at this point, second semester Altitude Honors class, I give you a lot of information. You kind of decide what you need to know and what you don't need to know. I've got an answer key for this floating around somewhere. I'll pass that around. Maybe you guys pack, take a picture of it and whatnot. Now, what I wanted to kind of do here with a few of these is I wanted to go in and start with like number 4. Devin, I'm on that review thingy I emailed. What? So I do 4 and yeah. see how the instructions tell you no fractional exponents in the denominator and all positive values? That's the standard rule, guys. So as you go through these, you got to remember there's a couple of things that you can do, and it doesn't matter the order in which you do them. You just got to make sure you don't skip a step. So here I've got 4 times 2, which is 8. Good, I'm glad nobody pressed that on their calculator, so there's that. Now both of these variables, the ends, are both negative. And we don't like negatives, we like positives, so how do we make those ends positive? Send them down to the bottom, the denominator. That thing. Now, we have the same base, different exponents for multiplying. What do I do with the exponents? We add them. This one's pretty easy. You can probably figure it out. What's a half and a fourth? 3/4. Good. So you get 8 to the n to the 3/4. But that goes against the instructions. The instructions say no fractional exponents in your denominator, which means add a fourth. Very good. So I have to add a fourth to the top and bottom to keep it balanced. My final answer then becomes 8 n to the 4th over n. Okay. One of the things that I do know that shows up also from time to time when you have this style of problem is that, and I started writing on the whiteboard here earlier and I was showing Sawyer about it, is, can I go to a clean one real quick? I don't want to get ahead of anybody here. One of the things that does happen from time to time is that, let's say you have x to the 7/3 over x squared. I have no fractional exponent in my denominator, but I have fractional exponent in my numerator. When I have fractional exponent in my numerator that is greater than 1, that's when you can still simplify it. Does that make sense? Because if you think about it, if I rewrite 2 in terms of thirds, how much would that be? 6/3. Good. This is another way of saying that this is and then who wins? The top does. So I can bring up the 6/3 and this will just give me x to the third. That's about as goofy I think of any of these ever get. You see that from time to time mixed through, just so you guys saw that. Okay. What's that? No, I'm just reminding you because I think there's another problem on here that's similar to that. I just want to make sure you guys saw that tonight, so that way you remember if you see that again. Okay. I'm gonna say something. Good, I didn't want to talk to you. I'm so good. Look at 8. So I'm going to make it a point to make sure that whenever you have to take nth roots, square roots, cube roots, fourth roots, whatever, they're going to be ones you'll be able to figure out without having to bang your head against a wall, I hope. So if you think, what are 3 numbers that you multiply together that are the same number that gives you a negative 1,000, what do you think it is? Good. That's not too bad, right? So you bring out the negative 10. So you're going to be 80 times negative 10. I know I'm going to have some nth root to worry about. But what was my trick when I'm simplifying nth roots to variables? We're dividing. You're thinking about division. Okay. Does 3 go into 2? Nope. Can't simplify any out. So I leave 2, the x's in. Does 3 go into 3? Third time's a charm, but we'll get to the next quarter. All right, you're going to get the next one, I know. So I can take 1 out, I've got none left. All right. So how many times does 3 go into 7? There it is. See what I meant there? Third time's a charm. It worked. Yeah, it was a play on words. Shut up. Did you get that? We've done a ton of those. I just wanted to make sure you guys saw that again. Yes? What do you mean? Oh, yeah. I did that first hour. I just got it going. 80yz squared times the cube root of x squared z. It's, sounds like a good time there. Yes, ma'am. Yeah. Just like the negative 1 out front. So on number 5, we've got negative 1 square root of 18x to the 4th. Oh, that doesn't matter. What is the square root of 18 simplified to be? 3/2, very good. So you get negative 1 times 3, then I have root 2 here. And how many times does 2 go into x to the 4th? So you wind up with negative 3x squared root 2. I was just trying to help it along a little. You know, sometimes people get going, today, Junior. Let's look at 10. Now, when I get these really ugly ones, my suggestion, you know, I've never given a good suggestion in my life, is I would first move the things that I know that are negative. So I'll take the x to the negative 4th, y to the negative 3/2, move those down. I'm going to take the x to the negative 1 and move that up. I'll do that first, because just get that out of the way. I don't want to try and do too much. And then I have that parentheses stuff to worry about. What I'm doing here is I'm just leaving the parentheses open for right now. So that way, because I know I'm going to have to fill it in with the power to power rules. So when I have power to power, what do I do with my exponents? I multiply. So I do 3/4 times negative 5/3, and I get, which is negative 5/4. Okay? Power to power, power to power. And then y to the 1/4 to the 3/4 becomes y to the 3/16. Now, in that string, I have a negative x value that can move up. But before I do that, notice I have a 1/4 and a 5/4. Negative 5/4, excuse me. Can't I combine those two right there? What's 1/4 plus negative 5/4? Negative 4/4, otherwise known as 1. So what I'm doing here is I'm kind of preemptively moving stuff. You know, I'm going to have a negative 1 here. Then I'm going to have a y. I have a 3/2. I have a 3/1. And then I have a y to the 3/16. So I know that I have that negative 1, which means where's it going to go? It's going to go up. So I'm going to write times an x here. I'm going to go back and just erase this. We've combined it and moved it. Now I just have to add 3/2, 3, and 3/16. Those aren't terrible numbers to work with because you've got a common denominator then of 16. So if I've got a common denominator of 16, this will be times 8, so I have 24. This is times 16, so I have 48, and this is there. 72, 75/16. Okay. So x squared y 75/16. Now I have to figure out how do I get to the next whole. Well, we count by 16. I have 16 times 2 is 32. I double that, so it'd be 16 times 4, which would be 64. So the next one would be 80, so I need 5 more 16ths. Okay. I'm just counting by 16 to see where the next whole is. And now I have 80 over 16, otherwise known as 5. And I have x squared Guys, I cannot stress when you do those types of problems, just slow down. Slow down. Which other ones of those there looks awful that you want me to walk through real quick, at least how to set up? 14? Sure. If I start to look at 14, okay. So before I get going too far on this one, I notice in my numerator I have a v to the 0. What is anything to the 0? It's 1. So I'm just gonna do this right away before I forget. I know this is nothing. So that gives me a v in my numerator. Now I have, before I move the negative 5/4 and the negative 3/4, I combine those together, right? What's negative 5 and negative 3? I'm adding. Remember saying thanks for adding. So you get negative 8. Negative 8 over 4 is negative 2. I'm just rewriting it as u to the negative 2 for now. Okay. My denominator, that's u to the 0. 1, so it just becomes 1 again. And now I have a negative 1/4 to the 1/4 becomes. What is 1 to the 1/4? Anyway, yeah, so you get v to the negative 16. Now, bring that up, bring the other one down. You get v. What's v times v to the 16th? 17/16. I know, it's okay. It's not that bad. It's just ugly. Oh, go to the next slide real quick. I got a minute here before we run out too much time. Inverses. What do? Flip flop and resolve for y. Notice I did not put on the inverse domains, which means that way it's a little bit cleaner. You don't have to worry so much. Yes, I don't think I have any of those on here, do I? Waste of time, isn't it? Especially if it says verify that they are inverses. They're already inverses. Why do I need to show you that they are? I mean, I don't know, whatever. But I want to show you these notations here. This is 19. The CUDA worksheets, they use a different style of nomenclature when they're talking about composite functions. I bet you can figure out what that means. What does that mean? Nope. Yeah, this is the same thing as saying f of n plus g of n. They just write it differently. It means the exact same thing. Same idea if you look at 21. 21 says f of x is 4x minus 2. What is f of x? This means that if you look at it on that little circle, it means the exact same thing. It means the exact same thing as f of x. That's when it just sometimes the nomenclature gets changed. I think that's how I typed it because it was what the review that I made real quick looked like. So I want to make sure you see the kind of same ideas. Okay. What is that an open dot or a closed dot? What do you think it means then? Exactly. So in 22, that h dot g of x just means h of x times g of x. So you just multiply the two functions together. The open circle is f of x. So that means I would write down the f equation. Then I would surround it with the f equation. Be careful. I know I did this on the examples like this in the past couple of days when you had composites. I tend to forget that minus 2 with the tack on. You guys yelled at me a couple times. So don't do that. Remember it. So you get 16x minus 8 minus 2. 16x minus 10. And then the good old-fashioned equations. For example, number 23. There's nothing else you can do. Because if you're not solving for anything, it's just find the composite of the functions. When you want to do something first, can't. Now, this is the style problem that you can't just square and then all of a sudden it's still got a plus 1 on it. Because there's a plus 1, that means you'd have terms you'd have to FOIL out. Ew, you're right. So what I would do, I would move this guy to the left. You get 9 minus x half minus 6 minus x half 1. Now this, it winds up being a difference of, well, when I square it, it's just don't square it. Right? Yes, this is that long style problem. Now, depending upon, what's that? It very well could be. Now, when you go through this, I want you to remember this. When you square this, this is the same idea as a minus b quantity squared. You get a squared minus 2ab plus b squared. Okay. Where this is a. Well, what's a to the half squared? A. What's b to the half squared? B. So what happens here is that in the middle, you wind up, well, first of all, you'll get 9 minus x minus, once you jump, then you'll have plus 6 minus x at the end. There's your a squared and your b squared. The middle, you're going to get 2, 9 minus x to the half, 6 minus x to the half, and 1 squared is 1. Okay. What's that? Remember, if you had x minus 2, you get x squared minus 2x minus 2x plus 4. That's where you double the middle term when you have the same thing twice. From here, I combine my terms on one side. I'm going to get 15 minus 2x and minus 2 stuff in the jump is 1. I'm just not writing it out, I'm running out of time. You okay with that? All I do is combine like terms. What numbers? There's A, there's B. Yep. Yeah. They're let A equal 9x, 9 minus x to the half. So that's a squared. If I square this, I get 9 minus x. If I square this, I get 6 minus x. Okay. Moving these over, I'm going to get negative 2, dunk in the parentheses, equals negative 13 plus 2x. Divided by my negative 2. I still have my dunk in parentheses. I'm running out of time, so I'm going to finish this out so you can see it. And I get that. Now, since I have junk times junk to the half power, I can alleviate that half power by doing what? Then I square it again. you wind up with the 9 minus x, 6 minus x. You'll have to FOIL and solve. It works out cleanly, but it's just a pain that you have to show all the steps. If you get questions on something like that before school tomorrow, I'll be here. Yes, ma'am. Oh, okay. This is right. Silver one. That's a weird one.